flip a switch, and a tiny glass ball instantly bursts into a blinding light. The process behind that glow starts far away from the bulb itself. To see how it works, we have to shrink down inside the copper power cord. At this level, electricity is revealed as energy physically moving through the wire. Inside the metal are billions of tiny, separate particles called electrons. These act as the microscopic delivery trucks that carry power from the outlet to your lamp. When you turn on a device, these electrons begin streaming forward in a high-speed flow toward their destination. Electrons require a continuous loop, a circuit, connecting power to the bulb like a racetrack. But what happens if a gap appears? Snap! The flow stops instantly. Turning a switch off pulls the wire away, creating a gap electrons cannot jump. This broken loop stops electricity from reaching the bulb. It is exactly how we control power in our homes. Once the electrons reach the bulb, they enter the filament. This is a super thin wire standing in the center of the glass, resembling a tiny strand of metal spaghetti. The narrow filament creates a microscopic bottleneck. Electrons are forced to squeeze through, bumping into atoms with intense friction. This constant bumping generates massive heat. Eventually, the wire becomes so hot it begins to glow, throwing off visible light. This process generates temperatures over 4,000 degrees Fahrenheit, as hot as molten lava in a volcano. That's why a lit bulb is dangerous to touch. Traditional bulbs operate by forcing electricity to generate intense heat, turning that thermal energy into the light we use to see. Modern LEDs use specialized materials that allow electrons to emit light as they pass through, without the need for friction or extreme heat. Since they don't get hot, they're much safer. But do you know why the old light bulb failed its math test? It just wasn't too bright. Because LEDs stay cool, they convert a much higher percentage of electricity into light, providing the same brightness while using significantly less energy. Time for the lightning round. Question 1. What are the tiny particles that move through wires? Electrons. Question 2. What is the thin, glowing wire inside an old-style bulb called? The filament. Question 3. What do we call the complete loop that electricity travels on? A circuit. You nailed it! Hit that subscribe button right now to join the lab crew for our next mission. Here is your cheat sheet. 1. Electricity is moving electrons. 2. They need a closed circuit to flow. 3. In old bulbs, the filament gets so hot that it glows. Look at the lights in your home with a grown-up. See if you can identify which bulbs feel warm and which ones stay cool. Now you've mastered electricity. But what about the sky? How do heavy raindrops form, and where does all that water actually come from? Click right here to find out.